For this problem, we have to figure out the fourth number she will say. We know that she counts by 2 starting at 10. So let's count by 2 starting at 10. Our first number would be 10. Our second number is 12. Our third number is 14. And our fourth number is 16. So the answer to this problem is 16. For this problem, we have to figure out the fourth number she will say. We know that she counts backward by 2 starting at 20. So let's count backward by 2 starting at 20. So the first number would be 20. Our second number would be 18. Our third number would be 16. And our fourth number would be 14. So that means the answer to this problem is 14. For this problem, we have to figure out how many bags he will fill on the fifth day. We know that on the first day he fills 5 bags. On the second day he fills 8 bags. On the third day he fills 11 bags. Let's draw a table to help us solve this problem. So we have the number of days on the left and the number of bags on the right. On the first day, he fills 5 bags. On the second day, he fills 8 bags. And on the third day, he fills 11 bags. Let's see if we can figure out a pattern. Going from the first day to the second day, we see that the number of bags increases by 3. Going from the second day to the third day, we see that the number of bags also increases by 3. So that means for each day, the number of bags increases by 3. So for the fourth day, the number of bags is equal to 11 plus 3, which is 14. On the fifth day, the number of bags is equal to 14 plus 3, which is 17. So the answer to this problem is 17. For this problem, we have to figure out how many pepper plants there are. We know that in the first row he plants 1 pepper, in the second row he plants 2, in the third row he plants 4, and in the fourth row he plants 8. We can draw a table to help us solve this problem. So we have the row and the number of peppers. In row 1, he plants 1 pepper. In row 2, he plants 2 peppers. In row 3, he plants 4 peppers. And in row 4, he plants 8 peppers. Let's see if we can figure out a pattern to figure out the number of peppers in the fifth row. Going from the first row to the second row, we can see that the number of peppers doubled. Going from the second row to the third row, the number of peppers doubled. Going from the third row to the fourth row, the number of peppers doubled. So that means the pattern is that the number of peppers doubled for each row. So for the fifth row, there will be 16 peppers. To figure out the total number of pepper plants, we can add up all of these numbers. So we can do 1 plus 2 plus 4 plus 8 plus 16. And we get 31. So that means the answer to this problem is 31. For this problem, we have to figure out the total of these equations. So let's solve the first line first. Solving for the first line, we get a total of 21. Looking at the second, third, and fourth line, we see that all of them are identical. So that means all of them also equal 21. Finally, we can solve for the last line. Solving for the last line, we get 15. To figure out what all of this is equal to, we can add up these 5 numbers. So we can do 21 plus 21 plus 21 plus 21 plus 15. And we get 99. So that means the answer to this problem is 99. For this problem, we have to figure out after how many stops the train will be full. We know that a train can hold 78 passengers. We also know that the train starts out empty and picks up 1 passenger at the first stop, 2 new passengers at the second stop, 3 new passengers at the third stop, and so forth. So we can make a chart to help us solve this problem. And the chart would look something like this. As you can see, at the first stop there is 1 passenger. At the second stop, there are the number of passengers at the first stop plus 2. At the third stop, there are the number of passengers at the second stop plus 3. At the fourth stop, there are the number of passengers at the third stop plus 4. If we continue this pattern, we get to the 12th spot where there are 78 passengers. So that means the answer to this problem is 78 passengers. For this problem, we have to figure out the 25th shape. We know that he is starting with a triangle and ending with another triangle. So let's draw 2 triangles. We also know that in between the triangles, he has a circle to the left of a square. So let's draw a circle to the left of a square. So this is the pattern we have here. Now let's figure out the 25th shape. As we can see, this pattern repeats every 4 shapes. So we can divide 25 by 4 to find the remainder and see what shape it ends on. So 25 divided by 4 gives us 6 with a remainder of 1. So that means this pattern repeats 6 times and ends on the first shape. And the first shape happens to be a triangle. So that means the 25th shape is a triangle. For this problem, we have to figure out the total number of photos in the display. We know that he puts 1 photo in the first row, 4 photos in the second row, 7 photos in the third row, and 10 in the fourth row. We can make a table to help us solve this problem. So we have the row and the photos. In the first row, there is 1 photo. In the second row, there are 4 photos. In the third row, there are 7 photos. In the fourth row, there are 10 photos. In the fifth row, there are 13 photos. In the sixth row, there are 16 photos. In the seventh row, there are 19 photos. In the eighth row, there are 22 photos. In the ninth row, there are 25 photos. And in the 10th row, there are 28 photos. To figure out the total number of photos, we can add up all of these numbers. So adding all of these up, we get 145. So that means the answer to this problem is 145 photos. For this problem, we have to figure out what day Elizabeth will collect exactly 96 seashells. We know that on the first day she collects 3 seashells. We also know that each day the number of seashells she collects is double the number of seashells she collected the day before. So let's make a table to help us solve this problem. So we have the day here, and the number of seashells here. On day 1, she collects 3 seashells. On day 2, she collects 6 seashells because 6 is double 3. On day 3, she collects 12. On day 4, she collects 24. On day 5, she collects 48. And on day 6, she collects 96. So that means the answer to this problem is 96 seashells. For this problem, we have to figure out how many boxes, counting all sides, are there altogether. We know that there are 4 separate large boxes, so let's draw 4 boxes. We also know that inside each of these large boxes, there are 3 separate small boxes, so let's draw all of the small boxes. Finally, we know that inside each of these small boxes, there are 2 separate smaller boxes, so let's draw all of the smaller boxes. Now let's figure out the total number of boxes. We have 4 large boxes, 12 small boxes, and 24 smaller boxes. So adding up 4, 12, and 24, we get 40. So the answer to this problem is 40 boxes. For this problem, we have to figure out how many white rhombi there will be if he uses 64 small right triangles. We know that he uses 12 right triangles to make the following design. In case you can't see the right triangles, this is what they look like. As you can see, each rhombus is composed of 4 of these small right triangles. So if he uses 64 small right triangles, that means to figure out the number of white rhombi there will be, we can do 64 divided by 4, and this gives us 16. So that means the answer to this problem is 16 white rhombi. For this problem, we have to figure out where the 5th mark is. We know that there are 8 marks evenly spaced from each other along a meter stick. We also know that the first mark is at 27 centimeters and the 8th mark is at 62 centimeters. So let's draw this out. So we have the first mark at 27 centimeters and the last mark at 62 centimeters. We know that there are 8 marks in total, so we have to draw 6 more marks as we already drew a mark at either end. So let's draw 6 more marks. Now let's figure out the distance from the first mark to the last mark. So we can do 62 minus 27, and we get 35. We know that all of the marks are evenly spaced, so let's figure out the distance between each of the marks. We have 7 spaces here, so we can do 35 divided by 7 to get the distance between each mark, and this gives us 5. So that means the distance between each mark is 5 centimeters. Now let's figure out the centimeters of the 5th mark. So we have the 5th mark here. So to figure out the distance from the 5th mark, we can do 27 plus 5 plus 5 plus 5 plus 5, as there are 4 distances from the first mark to the 5th mark, and this gives us 47. So the answer to this problem is 47. For this problem, we have to figure out how many dimes will be in figure 100. Looking at the figures, we see that the number of dimes in each side is equal to the number of the figure. So for example, in figure 4, there are 4 coins on each side since the figure number is 4. To figure out the number of coins in this figure, we can add up the length of all of these sides and then subtract the repeated coins, which are this coin, and this coin, because these coins are counted twice because they are counted in both of these sides. So to figure out the number of coins in figure 4, we can do 4 plus 4 plus 4 minus the 3 repeated coins. So to figure out the number of coins in figure 100, we can do 100 plus 100 plus 100 minus the 3 repeated coins, and that gives us a total of 297. So the answer to this problem is 297. For this problem, we have to figure out how many sticks she needs to make a 10 by 10 grid. Let's look at the 2 by 2 grid here we have on the right, and we see that it's composed of 3 columns of 2 sticks each and 3 rows of 2 sticks each, which gives us a total of 12 sticks. Now let's look at a 3 by 3 grid. And we see that this 3 by 3 grid is composed of 4 columns of 3 sticks each and 4 rows of 3 sticks each, which gives us a total of 24. So that means a 10 by 10 grid would be composed of 11 columns of 10 sticks each and 11 rows of 10 sticks each, which gives us a total of 220. So the answer to this problem is 220 sticks. For this problem, we have to figure out how many strikes can be heard at one 24-hour period. We can split the 24-hour period into two 12-hour periods because the two 12-hour periods are identical except for the AM and PM part, and the AM and PM do not matter in this problem. Based on this problem, we know that the number of strikes corresponds to the time. So if we have 9 AM and 9 PM, we will hear 9 strikes. So that means the number of strikes in the 12-hour period is equal to 1 plus 2 plus 3, and so on until we add 12. Because at 1 o'clock, there is 1 strike. At 2 o'clock, there are 2 strikes. And at 3 o'clock, there are 3 strikes. And so on until we reach 12 o'clock. So adding all of this up, we get 78. And since a 12-hour period is only half of a 24-hour period, we have to do 78 times 2 to get the number of strikes in the 24-hour period. So 78 times 2 is equal to 156. Now let's figure out how many times the clock strikes at the half an hour mark. We know that the clock strikes once at the half an hour mark, and in the 24-hour period, there are 24 half an hour marks, so that means it strikes 24 times. So to figure out the total number of strikes in a 24-hour period, we can do 156 plus 24, and we get 180. So that means the answer to this problem is 180 strikes. For this problem, we have to find how many dots will be in the 100th figure of the sequence. So let's use a table to help us solve this problem. So we have the figure on the left and the number of dots on the right. For our first figure, we have 9 dots. For our second figure, we have 12 dots. And for our third figure, we have 15 dots. Going from the first figure to the second figure, we see that the number of dots increases by 3. Going from the second figure to the third figure, we also see that the number of dots increases by 3. Looking at the first figure, we see that we have the initial value plus 3 0 times, so we can write the number of dots for the first figure as 9 plus 0 times 3, because we add 3 dots 0 times. We can write the value of the second figure as 9 plus 1 times 3, because we add 3 once. We can write the value of the third figure as 9 plus 2 times 3, because we add 3 twice. So that means for figure n, the number of dots is equal to 9 plus n minus 1 times 3, because as you can see in figure 3, we add n minus 1, which is 2, times 3. For figure 2, we add n minus 1, so we do 2 minus 1 and we get 1 times 3. We can simplify this equation by distributing n minus 1 times 3. So we have 9 plus 3n minus 3. So simplifying this, we get 3n plus 6. Looking at this problem, we have to find how many dots will be in the 100th figure of the sequence. So that means n is equal to 100. So we would substitute in 100 for n into this equation. So we have 3 times 100 plus 6. And this is equal to 300 plus 6, which is equal to 306. So the answer to this problem is 306. For this problem, we have to find how many numbers between 1 and 99 are the product of two even numbers. We can write the product of two even numbers as even times even is equal to some number. If a number is even, that means it is divisible by 2. If we have the product of two even numbers, that means the number is divisible by 2 twice. So that means the number is divisible by 2 times 2, which is 4. So the number is divisible by 4. If a number is divisible by 4, it must be possible to write the number as a product of two even numbers, because it contains at least a pair of factors that contain at least one 2 in each of them. If a factor contains a 2, it is even because 2 multiplied by any number is even. So that means all numbers divisible by 4 can be the product of two even numbers. To get the answer, let's find how many numbers between 1 and 99 are divisible by 4. The largest number divisible by 4 that's smaller than 99 is 96. So we can do 96 divided by 4 to get the answer. 96 divided by 4 is equal to 24. So that means the answer to this problem is 24. For this problem, we have to find the value of n. We know that she starts at 2 and counts by 3s until she reaches 449. We can draw a table to help us solve this problem. So we have the term on the left and the value on the right. When the term is 1, the value is 2. When the term is 2, the value is 5. When the term is 3, the value is 8. And when the term is 4, the value is 11. Going from the first term to the second term, we see that it increases by 3. Going from the second term to the third term, we see that it also increases by 3. And going from the third term to the fourth term, it increases by 3. Looking at the first term, we see that we have the initial value and we add 3 0 times. So we can write the value of the first term as 2 plus 0 times 3. Since we add 3 0 times, we can write the value of the second term as 2 plus 1 times 3. Because we add 3 once, we can write the value of the third term as 2 plus 2 times 3. Because we add 3 twice, we can write the value of the last term as 2 plus 3 times 3. Since we add 3 times. Now we can look for a pattern. When we have the term 4, we add 3 4 minus 1 times. When we have the term 3, we add 3 3 minus 1 times. So when we have the term n, we add 3 n minus 1 times, so we can write the value as 2 plus n minus 1 times 3. Now let's refer back to the problem. We have to find the nth number when it is equal to 449. So we can write the equation 2 plus n minus 1 times 3 is equal to 449. We can distribute the n minus 1, and we have 2 plus 3n minus 3 is equal to 449. Simplifying this equation, we have 3n is equal to 450. Dividing both sides by 3, we have that n is equal to 150. So that means the answer to this problem is 150.